Okay, this is just a test to kind of go through the Unit 6 review for AMDM. The first question that we're going to be looking at here is we're looking at how to go about showing your calculations for finding a job. So the first job we have is Thomas. He's a full-time position that pays a salary of $42,300 per year. They want to know what is the pre-tax income. So we're going to take that $42,300 and we're going to divide it by 12. Since there are 12 months in a year, that's going to give us a pre-tax monthly income of $3,525, and we want to write this as a money amount. So that would be our pre-tax. The next question here is asking what our income would be monthly after our taxes. So we have a 6.2% Social Security, a 1.45% Medicaid, and a 15% income tax. So the first thing you want to do is take all of those amounts and add them up. And when you do that, you get a total of 22.65, and that's percent. So to figure out your after-tax income, you want to take your pre-taxed income and subtract the amount that you would pay in taxes. So to figure out that amount, you take your $3,525, your pre-tax income, and you multiply it by the percentage. But we need to convert this percentage to a decimal, so it's 0.2265. We want to move that decimal place over 2, and that is going to give us an after-tax income of $27,2659. So that would be our after-tax income. All right, so on this next question, we have a full-time position that pays an hourly wage of $32. So what we want to do here is we're going to have a $32 salary times 8 hours a day, that's your daily salary, times 5 days a week, times 52 weeks in a year. This is going to give us an annual salary of $66,560. The next question you'll recognize from before, what is the monthly income? Again, we want to take that annual salary and simply divide it by 12, since there's 12 months in a year. And that's going to give us a monthly salary of $55,046.67. So then to calculate your after-tax monthly income, we're going to use that same tax percentage as we did from the first problem, which was 22.65%. So we're going to take that monthly income pre-tax and we're going to subtract out the taxes. And again, the way we calculate our taxes is we want to take that pre-tax monthly salary and multiply it by our percentage of taxes. And again, don't forget to convert that to a decimal first. This is going to give us an after-tax income of $42.90.35. So that will be our after-tax income. All right, so this next problem here has to do with working on a commission. So for this particular problem, we're actually going to figure out our monthly gross income first, and that's because his income is based on his commission per month. So it says here if he gets 6% of his sales, so since he had $120,000 in sales, we want to multiply that by 0.06. Now this is going to give us our monthly income, which is going to be $7,200 or $7,200. So that'll be our monthly income. I'm going to go back up here for my annual income, and I'm going to take that monthly income and I'm going to multiply it by 12, since there's 12 months in a year. And this will give me my annual income of $86,400. Now, For his after-tax monthly income, remember we're using the 22.65% taxes. So we're going to take that monthly income once again, pre-tax, minus our taxes, and our taxes are going to be $7,200 times 0.2265, converting that to a decimal. And this is going to give us our after-tax income, which is $5,569.20. Now for this next question, it says if you had to choose between Stephen's job and Scott's job, which one would you take? This is kind of an open-ended question. Just to give you a quick reminder, Stephen's job after taxes gave him an income of $42,000 or $4,290.25. So some of you may choose Scott's job, which has greater income. But as long as you can justify your answer on why you would choose one versus the other. Some of you may say that Stephen has a more steady income because his is an annual income, whereas Scott's is based on commission. And if he doesn't do the sales any particular month, then that could cause an issue. So again, it's really going to be based on what you think is the best choice. All right, here we're going to ask a question that's actually kind of just based on more or less an opinion, if you will, as to the difference between simple interest and compounded interest. The things I'd like you to go away with here is going back to Unit 4, what the difference is between simple interest and compounded interest. Simple interest basically means that you add the same amount each month, and it's based on the original principal. So you're adding the same amount to the account each period, whether that be monthly, yearly, or etc. Now this is what we call a linear regression. So this is going to be your line, this is going to be your arithmetic. That's a sub n is equal to a sub 0, which is your initial amount, plus the common difference times n. So this goes back to Unit 4 when we did linear arithmetic sequences. Your compounded interest, on the other hand, is dependent upon the amount that is already in the account. So this adds a different amount each month or each period depending on how much is in the account. So this is based on the amount in the account. So this is what we call our exponential function. So if you're compounding interest, then you have an exponential function, and just to give you a quick reminder, that was a sub n is equal to the initial amount times the rate raised to the nth power. So this is where those concepts come in from our previous unit, Unit 4. All right, here we're going to show you the difference between simple interest and compounded interest. The first account is simple interest at 5.6%, and that is compounded each year, so that means annually. It is simple interest. We're starting off with $1,500. To calculate simple interest, it is simply your principal value times 1 plus your rate. In this case, our principal value is $1,500 and our rate is 0.056, so we want to convert that to a decimal. That's going to give me $84, and it's going to be the same $84 that is added each year. This is the difference when you have something. This is your simple interest account. So this will be $1,584. Add another $84, we get $1,668, then $1,752, $1,836, $1,920, and $2,004. Now on the second account, we have compounded monthly. So we have a 4.8% interest rate, which is slightly lower. But this is going to be compounded interest, and compounded interest works differently. We're still going to start off with that initial $1,500. So to figure out how much interest we earn after 1 year, our future value is equal to our present value, times 1 plus our rate. This time we divide it by the number of times it's compounded per year, which in this case is 12 times per year. And it's raised to the nth power. So we're going to take that $1,500, we're going to multiply it by 1 plus 0.048 converted to a decimal, divided by 12 since it's compounded monthly. We're going to raise it to the 12 times 1 power since we're only calculating our interest filling out the table 1 year at a time. So that's going to give me 1573.61. Now to figure out the next year, I have to take that previous term, or our new balance rather, 1573.61, and again multiply it by 1 plus 0.048 over 12, raised to the 12th power. So notice the difference here is we're using the new amount, or the new balance that we have in our account. This is going to give me an interest rate of a new balance of 1650.82. Now, we're going to keep continuing that this way. This amount here actually breaks down. We're going to take our new balance here. This is actually 1.004 raised to the 12th power. So our new balance here would be 1731.83, and you can keep going or pause now to see if you can do that on your own. But then we want to go to 1816.81. Then we have 1905.96, and then we have 1999.49. All right, so this is our two tables. You'll notice that the amounts aren't that far off, but we've only calculated up to the 6th year. So for the first question here, it says to write an equation for the balance B of the first account, that's my simple interest account, and after the number of T years, so they're telling me what variables to use, and how much money will I have after 15 years. Remember I told you simple interest is A sub n equals A sub 0 plus D of n. A sub 0 represents your initial or your first amount. So this will be B equals 1,500 plus my common difference here is the interest that I've earned each and every year, which in this case is $84 times T for years. So there is the actual equation that I would be using. To calculate what it would be after 15 years, I would simply insert 15 for the number of years. So after 15 years, she's going to have a balance of $2,760. Now for the second account, and we're using the letter A here, we want to do the same thing, write a general equation. Remember I said that this is your exponential account, so this is A sub O times your rate raised to the nth power, or your time. So in this case it would be A equals, my initial amount is still 1,500. Remember we calculated over here that that rate between each one of them is 1.004. Because the rate is calculated slightly differently, we have to take into consideration the 1 plus 0.04 divided by 12 since it's a monthly. And this would be 12 times T. 12 again being because it's a monthly income, or compounded monthly, and T is the number of years. So again, to figure out what that is after 15 years, using the letter A, it would be 1,500 times 1.004 raised to the 12 times 15. So this time we get that her income would actually be $3,077.28. So now when you originally looked at the table, you might think the simple interest was the way to go. It looked like you had more money. But you'll see that after a period of time, your compounded interest is the way to go, because over time your money will grow much faster. So that's the difference between having simple interest, which is simply linear, and then compounded interest, which is exponential. Okay, I just want to say that on the previous slide 6, I put a YouTube video on there so that you could look at that and hopefully get that recording values as well. This next question here has to deal with Maggie wants $10,000 in 10 years. How much money should she invest today if she has an annual interest rate of 5.1% that's compounded annually now, or quarterly? It is compounded, so your future value is equal to your present value, the principal value, that's the money you put in, 1 plus our rate divided by n, the number of times it's compounded per period or per year, and then n times t is the number of years. So the question here is, how do we get $10,000? Well, how much money does she have to put in to the account? This will be 1 plus 0.051 divided by quarterly is 4 times a year. So that's 4 times and then 10 years. So in order to find the present value, what you want to do is take this $10,000 and divide it by this entire amount in order to get your answer. So that is going to give you the answer of $6,024.35. The next couple of problems have to do with using the TBM calculator. What I'm going to do is go ahead and show you how to fill in the table, tell you what your answer would be, and then I'll also post a link on an additional slide that actually shows you how to use the TBM calculator. All right, so your TBM calculator, to get to the TBM calculator on your TI-84, you want to hit the Apps button. And then once you hit the Apps button, option number 1 is Finance, and this is where you want to enter all your values into your table. And under Finance, option number 1 is the TBM solver. So we always want to go into apps depending on what we're trying to solve, etc. Each one of these means something different. I'm going to go a little slow on this first table. N is a combination of that whole NT. So it's the number of times something's compounded per year times the number of years. So in this particular problem, we have something that's compounded semi-annually, which means 2 times a year. So little n is equal to 2 times, and the question here is plans to retire in 37 years, so little t is 37. And this is actually how I enter it right into my TBM calculator. I literally do 2 times 37. Now this will give you a product of 74. Now it's asking you how much do we need to invest. So this is the value that you're looking for, okay? So this is what I want to know the answer to. When you get to this portion of your TBM calculator, you'll actually enter a value of 0 because that's what you're looking for. FV stands for future value. I want to end up with $100,000, so I'm going to put that in. C/Y is, again, that little n. How many times is it compounded per year? Again, semi-annually means 2 times a year. And P/Y is also going to be 2 times a year because that's also n. We are not making any payments, so that's 0. And here's something that's a little different. Your interest rate, when you put it into the TVM calculator, you actually enter it as a percentage. So again, to get into the TVM calculator, you're going to hit the apps button on your calculator, choose option 1, which is finance, then option 1, which is the TVM solver. You're going to place all these values in. We're looking for the present value. That's our the value we want. So when we initially put it into the TVM solver, we're going to put a value of 0. Now, go ahead and quit. You do that to get back to your home screen. And again, choose the apps button, followed by option number 1, which is finance. And then this time, since we're looking for the present value, on our TVM calculator, that's going to be option number 4, which is TVM and then an underscore present value. And that's going to give us our present value. Now when you do that, it actually comes up as a negative amount. So it's the answer that should appear on your calculator is negative 87.30.20. So when it comes up in your calculator, it's going to come up as a negative number. What that means is that's how much money you have to give to the bank. The answer to the question is $8,730.20. So that would be the amount of money that you'd have to invest. All right, so on our next slide here, I'm going to go through this a little quicker. Again, we're going to enter all these amounts. Just real quickly one more time, go to apps, choose option number 1, which is finance, and then choose option number 1, which is your TVM solver. So this is where you are going to enter all of your values. On this particular problem, it says that it's compounded daily. There are 365 days in a year, so that's 365 for 12 years. So T is 12. Remember that 365 is also going to be your C/Y and your P/Y because that's how many times things are compounded. In this particular case, we want to know what our future value is. So we're going to be looking for future value this time. So that's where we're going to enter a 0 into our TVM solver in order to get the answer. We are investing $4,500, but when we put that into our TVM calculator, we need to put that in as a negative amount because we're giving that money to the bank. Payments and present values, those are always negative amounts. For this particular problem, we have an interest rate of 2.45. I actually put that 365 in the wrong spot. Let me just go ahead and fix that. Don't know what I just did there. Erased it all. Didn't mean to. We can just put these values back in real quick. 365 times 12. We have a negative 4,500. 0. This is the value we're looking for. 365. 2.45. There are no payments here, so we just simply have, again, this value here is the number of times it's compounded. So we're looking for our future value, so we want to go to that apps button again, choose option number 1, which is finance, and this time, since we're looking for the present or the future value, what we're going to do is choose option number 6, which is TVM underscore future value. And you should get, for an answer on this problem, $6,037.97. All right, on our next slide here, we're using the TVM calculator once again. So we're going to fill in the values into the table first, except this time we're going to be making monthly payments. Now this is going to be important. This means I'm adding to my account monthly. Interest is compounded monthly. It says he wants to have $15,000 in 20 years. So what do his payments need to be? Now, whenever you are dealing with payments, you're starting off with a present value of 0. We're looking for payments, so we'll also enter that as 0. Our end value. It's compounded monthly. He wants to have the money in 20 years, so that's 12 times 20. Our future value will be 15,000. Our C/Y and P/Y are also going to be 12 because those are the number of times it's compounded in a year. And our interest rate is 3.5. So to find the payment, we're going to again hit the Apps button, choose option 1 for finance, and this time to figure out what the payment is, that is going to be option number 2. So option number 2 is TBM underscore payment, and that also will come out as a negative amount. You should get negative 43.24 show up in your calculator. The actual answer is you'll make a payment of $43.24. All right, so on problem number D, start off the same way, filling out the table. I always find the table to be the most helpful. It says Rose has made regular payments of $250. So they're telling us what the payment is. Remember that when we put this payment into the calculator, we want to make sure that we calculate it as a negative value. In this problem here, it says we're putting it into an account for 16 years and she now has 20,000. What we're trying to figure out is what is the annual interest rate. So what we're looking for here, that's where our 0 is going to go, is the annual interest rate. Remember, because there are payments, we want to go ahead and put a 0 here. Now, she's making quarterly payments. So the way I would do this is, okay, so I noticed as I was going through this that there's a typo on your answer sheet. So I'm going to correct that while we're here. But, so quarterly payments, that's 4 times 16. Our payment is going to be a negative $250 because we're giving that money to the bank. We want our future value to be $20,000 and we are compounding 4 times per year. So go into the Apps button and choose number 1, which is your finance. And then this time you're going to choose option number, I believe it's 3. Let me just check real quick. Yes, option number 3, which is TVM underscore, and then your interest rate. And you should get 2.6 or 2.57, 2.6%. So that's a typo on your answer sheet right there. All right, our last question is the credit card balance type question. This is often very difficult for students because they have a hard time figuring out what the average daily balance is. I always say start with that beginning balance. I actually did a problem with a longer video for this, so I'm going to go ahead and just tell you that when you calculate all of this, you should come up with an average daily balance of $1862.63. And the way you calculate it is you'll notice that your first purchase is made on the 24th. So there you make a purchase on the 24th, you make another purchase on the 31st, another transaction on the 2nd, the 5th, the 15th, the 20th, and then the 21st. Is when you make your last transaction, which means for the first transaction, there's only one day that my balance started off, and you want to start off with whatever your previous balance was. So that's $1567.23. Then I'm going to go from the 24th all the way to the 30th. Since the 31st is when my next balance was. And what I'm going to do is I'm going to add that $45.67 that I paid in gas. And so I have a new balance of $1612.30. and the number of days that I'll be at that balance is going to be 7 days. Then on the 31st, until the 1st, which is the day before the 2nd, so that's going to be for 2 days, I'm going to actually, on the 31st, I made a purchase of $89.45, so now my new balance is $1702.35. Then from the 2nd all the way to the 4th, which is for 3 days, my balance, I had made another purchase on the 2nd. That was for $75.05. So my new balance for this period of time is $177.40. Then on the 5th, I made another purchase, and that was for $120.67. So from the 5th all the way until the 14th, which is 11 days, I have a balance of $1898.07. Now, at that point, on the 15th, I actually made a payment or got a credit, so I'm going to actually subtract $200, and that's going to stay my balance until the 19th. So if you need to, also you can do 15, 16, 17, 18, 19 to count your number of days, but that's going to be for 6 days. And that is going to be a balance of $1698.07. And then on the 20th, I made a purchase at a restaurant, so I'm going to add that amount in, giving me a new balance until the 21st, so that's only going to be for 1 day. And my new balance is $1723.85. Now, from the 21st until the end of the cycle actually ends on the 22nd, so that's 2 days. I am going to have a balance of $1677.96, and that's because I made received another credit of $45.89. So I must have returned something or made a payment. So to actually figure out the average daily balance, you take the number of days times the balance. So for 1 day, I had a balance of $1567.23. Plus for 7 days, I had a balance of $1612.30. Plus for 2 days, I had a balance of $1702.35. And you continue this all the way up to the last 2 days, I had a balance of $1607.96. Be very careful when entering this into your calculator. Now you'll notice down here it tells me that I have a billing cycle of 31 days. So I'm going to take this whole entire amount, divide it by 31, and that's how I get my average daily balance. Now to figure out the daily periodic balance, you just need to find what your APR is. My APR is 23.99, and divide it by 365 days in a year. So that's going to give me 0.239, well, it's converting it to a decimal, but that's going to give me 0.0657%. Now as a decimal, that's 0.000657, and this will be important because on the next slide we need to figure out what our new balance is. So to find our new balance, we always want to take our previous balance. Well, we first need to figure out what are going to be our finance charges. So to figure out the finance charges, you need to take your average daily balance, which we said our average daily balance was $1862.63. We want to take that average daily balance, multiply it by that rate, the 0.000657, 657, and then we have to multiply it by 31 because there's 31 days in the cycle. So our finance charges are $37.64. So to figure out our new balance, we want to take our previous balance of $1567.23, add any new charges that we've had, which were total up to $356.62. You can get your new charges are all located right here. Subtract out your credit, which in this case was $245.89. Here's my credit here. But then we need to also add in our finance charge, which is $37.64, which we calculated. So our new balance is going to be $1715.90. All right, and the last thing we want to do is calculate our minimum payment. It says our minimum payment has to be 3.2% of our new balance. So since our new balance is $1715.90, want to just multiply that by 0.032. We want to convert that to a decimal. That gives me a minimum payment of $54.91. Okay, so I hope you found all of this helpful. Please don't forget you can email me, pizzutol@fultonschools.org if you have questions, or you can send me a text or call me at 678-713-4727.